Question 2. We're told that the points -2, 6, -1, 3, and 0, 2 on the graph f of x is x squared plus 2 are moved by a linear transformation as shown in the diagram. In part A, we're asked to state the appropriate transformation matrix. This looks like a 90 degrees clockwise rotation about 0, 0. We can always get transformation matrices by considering what happens to the point with position vector 1, 0 and position vector 0, 1. With a 90 degrees clockwise rotation, this point is going to go here and this one here. So 1, 0 is going to go to 0, -1, and 0, 1 is going to go to 1, 0. The left column of the transformation matrix is given by what happens to 1, 0. The right column by what happens to 0, 1. We're now told that under a second transformation, this point here remains stationary, and this point here moves to 5, 1. So the point on the axis has stayed stationary. A point 1 unit distant from the axis has moved 2 units horizontally. We want the matrix for this. You should recognize this as a shear. If we consider 1, 0, because points on the x-axis have stayed stationary, this point will stay put. 0, 1 would go to 2, 1 because points a distance 1 from the x-axis have moved 2 units to the right. So our matrix is 1, 0, 2, 1. You can get the same result by calling your transformation matrix A, B, C, D, and then applying it to 2, 0, and applying it to this point here, 3, 1, and then solving the simultaneous equations that arise. Coming back to B part 2, we're asked for the new coordinates of 6, 2. So just apply our transformation matrix, and we get 6 add 4 is 10, 0 and 2, 2. In part C, we want to find a matrix which will take the points from their final positions after part B back to the original positions here. The transformations performed were, first of all, the rotation, followed by the shear. Remember, the first transformation needs to go on the right. So the combined transformation would be 0, take 2, 1 and 0, -1 and 0. We want the inverse of this matrix. The determinant is 0, take away -1, so that's just 1. we need to swap this diagonal and take negatives of the values on the other diagonal. This is the required matrix.